Hi there, hope you have a fantastic day today. This lesson I'm going to teach you limits. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. So what is a limit? A limit is to help us to find out what happens to the functions when we approach to a discontinuous point or a gap. So in order for a limit to exist at a point, so the left-hand side limit must be equal to the right-hand side limit. Now, for example, in this graph here, we want to find out the limit that approach to 1. So we can find out the left-hand side of the limit, okay, and then we find out the right-hand side of the limit, okay. So we can write limit of y, x approach to the left-hand side of 1. We can write 1 minus on top. So that means is 0.9999 and so on. Very close to 1. So somewhere along here, see, very close to -1 for the y value, right? So that becomes -1, approaching, right? So now we find limit of y that x approach to the right hand side of 1. So which is here. Very close to 1, okay? So approach to -1 as well. So therefore, equal -1. So you can see the left-hand side of the 1 and the right-hand side of the 1, the both limits are equal. So therefore, we can say limit of y, x approach to 1 is equal to 1, negative. There you go. This function here. So let's find out what happened when x approach to 0. So remember, in order for limit to exist, the left-hand side limit, which is equal to the right-hand side limit, okay? Otherwise, it doesn't exist, okay? So let's say we want to find out limit x approach to, let's say the 0 minus, left-hand side of 0, okay? So on the left-hand side of 0 is here. Very close to 0, right? So they're approaching to 1. So the y value is 1. So of course, I have to write y here, which is equal to 1. And limit of y when x approach to the right-hand side of the 0. Now, don't forget, left-hand side of 0 is just like -0.00001 and so on, right? It's very close to 0. And for the right-hand side, it's like this, 0.000, so 0, 1. So the closer to 0, the better, okay? So now, the right-hand side of 0 is here. Very close to 0 here, okay? So that is equal to -2. So you can see the left-hand side of the limit at x approach to 0 and the right-hand side, they're different. One is equal to 1 and the other one is -2. So therefore, limit of y, x approach to 0 does not exist, okay? So remember that left-hand side of the limit must be equal to the right-hand side of the limit, okay? In order for limit to exist at a particular point, okay? Now, second one. So if I want to find out what happened when x approach to 1, okay? So for example, so you can see that the limit at 1 doesn't exist because if I find the limit of the x approach to left-hand side of 1, so y must equal to, you can see it's, okay, to here, so approach to 1, okay, so 1. But then limit of y, x approach to the right-hand side of 1, so equal what? So on the right-hand side here, it doesn't exist, okay? There is no function there. So therefore, okay, it doesn't exist. So does not exist. So therefore, the limit at x equal 1 does not exist, okay? Just remember that. So therefore, there you go. So let's go through a few examples. So first one, so to find the limit, so first of all, we need to simplify first. And then we can substitute the value in, that is x equals 0. But at the moment, of course, you cannot substitute the value in, because if you substitute x as 0, so you cannot divide by 0 because the denominator becomes 0. So you cannot divide by 0. So therefore, we need to simplify the function first. So that is equal to limit x approach to 0. So I take the common factor out, minus 1 over x. And we cancel this out. So this is equal to limits x approach to 0, x minus 1. So now I can just substitute the value in. So when x is equal to 0, so as soon as substitute x is equal to 0, the limit disappears, okay? So 0 minus 1. So the answer is -1. There you go. Of course, you can check it by using calculator, because we know that the left-hand side of the limit must equal to the right-hand side of the limit. So I can either substitute 0.00001 and store in memory, and then I put that in the calculator, and it should give me the answer as well. Let's check it out. So I just put 0.00001. Of course, the more 0, the better, okay? It's approach to 0. So I just put like 40 will do. And I store that in memory I. Shift store I. Make sure you store that in memory I, because you cannot use different value for x, okay? X is, in this case, have to have same value, okay? Remember that. So you go fractions, alpha I square, and minus I, and then over I. So there you go. The answer is -1. If you put a different value that's very close to 0, and you should get -1, okay? Second one. So first step is we need to simplify first, but the numerator we need to factorize. To factorize this, let me just write this down first. So that is equal to limit x approach to -3. Now remember, this is negative. So therefore, we need to have 1 plus, 1 minus. So x plus, x minus. And two numbers timed together to give me 3. And the difference, because minus, is 1. So 3 is 3 times 1. And the difference is 2. But then, this is positive 2. So therefore, the larger number must be on the positive side. So this is 3 and 1 over x plus 3. Now, if you need to practice on these factorized skills, please check on the description below. I have put the link for you, okay? So now we just simplify this. And now that's equal to limit x approaching to -3, x minus 1. Now I can simply just substitute -3 in. So that becomes -3 minus 1. So the answer is -4. There you go. So let's check the calculator to see if we got it correct, okay? Now remember, the left-hand side limits must be equal to the right-hand side. So it doesn't matter if I put -3.00001 or -2.99999. Doesn't matter which one I put, okay? -3.000. This time I put a little bit closer to -3. So shift store in I. So now I do fractions. So I go I square, because x is x squared, so it's I square, plus 2 lots of x, that means 2 lots of I, and then minus 3, and go down, and then I plus 3. There you go. So the answer is -4. Now, this is very good techniques, okay, if you use calculator, because sometimes in your exam or test is multiple choice, you can just quickly put that in your calculator, okay? So you don't have to work out like this. Next one. So we need to, again, simplify first. To simplify, we need to factorize the numerator. So first of all, we have this is equal to limits x is approach to 9, and then x, so this is negative, so therefore we need to have 1 plus and 1 minus. And I just write this over x minus 9. Now, two numbers times together to give me 27, and the difference is 6. So 27 is equal to 9 times 3. So the difference is 6. So therefore that is correct. But then we want negative 6. So the larger number must be on the negative side. So 9 and 3. So now I can just simplify these two. So the answer is equal to limits x approach to 9, x plus 3. So now I can just substitute the 9 in. 9 plus 3. So the answer is 12. There you go. Of course, you can check the answer yourself by putting 9.000001 and store in memory A and just do the same process and you should get 12, okay? Please pause the video and try this one yourself. Hi, I'm back. How did you go? So let me go through them with you, okay? But before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into this. First one. So we need to factorize this first. So that is equal to limits x approach to negative 3. So the top one is difference of two squares. Now remember, a squared minus b squared will give me a minus b and a plus b. Or a plus b times a minus b. Doesn't matter, okay? So that will give me x minus 3 because 9 is 3 squared. So x squared minus 3 squared, okay? So that give me x plus 3. And the denominator, so we have plus. So therefore, we just copy this out. So that means x plus. Now, two numbers times together to give me 6. And then we add to give me 5. So 6 is 3 times 2. Because 3 times 2 is 6 and we add together is 5. So it doesn't matter where I put because both are plus. So 3 and 2 here. So now we can just simplify it. So this cancel out. So that will give me limits x approach to negative 3. So x minus 3 over x plus 2. So now we can just simply substitute x equal to negative 3. So that is equal to, so negative 3 minus 3 over negative 3 plus 2. So that will give me negative 6 over negative 1. So the answer is 6. There you go. Part B. So again, of course, we need to simplify first of all. So if you try to substitute x equal negative 1 in the functions, it won't work because you cannot divide by 0. If you substitute negative 1 in, the denominator should be 0, okay? So that's why we need to simplify it first. So let me just write this down first. So this one, the numerator, 2 is a common factor, so as x. So I take it out. So that will give me x plus 1 over, so the denominator is a minus, so we just write 1 plus 1 minus first. So now two numbers times together to give me 7, and the difference is 6. So that should be 7 and 1, because 7 times 1 is 7 and 7 minus 1 is 6. But then it's negative 6. So therefore, the bigger number must be on the negative side. That's it. So now that will give me, so I just simplify this. This you cancel with this. So now we have limits x approach to negative 1 to x over x minus 7. So now I just simply substitute the value in. So that will give me, so 2 lots of -1 over -1 minus 7. So that will give me -2 over -8. So that will give me a quarter. So there you go. Last one. So let me just write this down. That will give me limits x approach to 2. Now, this one here is difference of cube. So remember, a cube minus b cube will give me a minus b, and then a squared plus ab, and then plus b squared. So just remember that these two sides here always opposite. So that's all. That's how you remember. Now, if you need practice on those, of course, the descriptions has a link on this type of factorization as well. So you can practice if needed. Okay. So let's back to this. So that becomes, now remember, x cubed minus 8 is equal to x cubed minus 2 cubed. So that's why we have x minus 2 and then x squared, and x times 2 is 2x but opposite side, and then you plus 2 squared, which is 4, over, now this one is different of 2 squared. Again, a squared minus b squared is equal to a minus b and a plus b. Just remember that, okay? So 2 squared is 4. So that means x minus 2, x plus 2. And we just simplify this out. So this one and gone with this. So that is equal to limits x approach to 2. So we have x squared plus 2x plus 4 over x plus 2. So now we can just simplify x equal to 2 into this function here. So let me just move this up a bit. So that will give me 2 squared is 4, and 2 times 2 is 4, and we add another 4 over 2 plus 2, which is 4. So that will give me 12 over 4. So the answer is 3. There you go. I hope you got all of them correct. Thank you so much for watching. Bye.